video is about median, mode, and range. So the purpose of any sort of statistical analysis is to draw conclusions from data. When you have a lot of different data points, you want to have a conclusion that you can draw so that you can either make a decision or make some sort of statement about the data. So in this video, we are only going to talk about mode, median, and range. All three of those have different purposes and are useful in different situations. First, let's talk about discrete versus continuous data. So this is something that's important to understand when you're looking at data and deciding how to represent the data in a chart or a graph, or which kind of statistical analysis to use. So discrete can only have certain values like a number of people or a count of something. So for example, if I'm counting the number of people in the class, I can't have half of a person. With continuous data, that can have in-between values, or otherwise known as fractional values. So weight, so somebody could weigh 100 pounds, but they could also weigh 100.5 pounds. So there we can have partial pounds, partial inches, and the same with time and distance as well. Let's start with mode. So mode is the most frequent data point. So here in this situation, we have a survey. How many siblings do people have in the class or in a grade level? And you can see on this bar graph that most people have 2 siblings in this data set. So it's the most often, it's a count, and it's discrete data. So using mode or the most common response is useful for discrete data that can only have certain values, but not continuous data. So if I'm talking about weight, the mode is not going to be as useful because people can have fractional values of weights. It's less likely for 2 people to have exactly the same weight. But for discrete data like this, it is likely that people will have the same answer. Median, however, represents the middle of a set of data. So right now, we are only going to focus on data sets that have an odd number of terms. So the middle number right there is 17. That's the one that's directly in the middle. There's 2 numbers to the left and 2 numbers to the right. So this is useful for both discrete and continuous data. Okay, median is important when we're thinking about outliers. So this data set represents the number of box tops collected by the 5 third grade classes during week 1. So you can see, okay, we've got 12, 15, 17, 18, and then one class collected 275. But it wouldn't really be right for me to say that that represented the typical amount of box tops that were collected, because most of the classes, 4 of the 5 classes, collected much less than 275 box tops. Okay, that's an outlier, which means it's a value that's way different than the rest. So our median is still 17 because that still represents the center of the data set. So median has that specific purpose. It's not affected as much by outliers, but it represents the center of the data set. So you can kind of think about the typical response or the typical data point. Still 17. All right, so addition test grades or grades in general are a good way to use statistics. So Mrs. Jones wants to know how the students did on the latest math test. Here are the grades. The median is 85%. So she knows that that's the value that's directly in the center. So that's the middle value, 85, and then the mode is 90. That was the most common score. So both of these measures give her some information about how her students did on this particular test. 85 is kind of in the middle, but most students got a 90, or the most common score was 90 rather. The range is also important. So she wants to know, okay, what's the difference between the highest score and the lowest score? That would be 55 points. So the scores are pretty spread out. So one student got a 100%, but another student got a 45%. So based on that, Mrs. Jones might feel that the students didn't understand that addition concept as well. All right, so let's look back on her grades from last year for the subtraction test. So this is completely different set of grades. The range this time is smaller because the highest score was a 75 and the lowest score was a 45. That means that the scores are closer together than the scores on the addition test. On the addition test, the lowest score was also a 45, but the highest score was a 100, which means the students were kind of all over the place in terms of their understanding of the concept. Here on the subtraction test, the scores are lower generally, but the students are closer together. Range has a different purpose than median. All right, so thinking about how to find median, first you want to put the data in order from least to greatest, and then you just want to find the data point that's in the middle of the data set.